All right, hi there, everyone. Welcome for coming to the skills session on robotics and themed entertainment with Jake. Um, we're going to get started here really quickly, but as always, if you have any questions or suggestions for how to make the skill sessions better or have ideas for topics we can do that you'd like to see, feel free to shoot them to TEA@ND and or .edu, and we will be sure to take those into account. So I'll pass it off to Jake to get started.
Yeah, one thing I'll say too is as we're getting into winter break, after people's exams, I know here at Notre Dame we have like a 10-week winter break. We'll definitely be ramping up the sessions in like magnitude just because I know people are busy during the school year here. So we're trying to keep them pretty light for people so far. And then we've got some good speakers lining up for over winter break. Let me present my beautiful Canva. All right, welcome guys. So I'm going to be walking us through basically robotics and then how that looks in the themed entertainment scale. And I'm going to make sure I share my computer sound for a couple of the videos I have in here. I'm going to hide my floating meeting control. So I can't see your faces now because I had to go to the video sharing mode. So if you do have questions, please unmute because otherwise I won't know that you have a question. Awesome, let's go ahead and get started. So who am I and why am I qualified to sort of talk on this topic? So first, I am the president and design lead for Notre Dame's robotic football team, as well as the head coach. And I'm going to show a video in a second just to give you a sense of the scale. But we basically design robot football players to play against other schools, mostly around like the Midwest and the East Coast. A lot of fun, a lot of cool opportunities there. I also have spent a good bit of time in a research group with a professor on campus here. We're designing this jumping robot. And so that's like a picture of the CAD model we were working. You can see that black line is kind of like the trace curve of the foot of the robot. And we were trying to get it to jump perfectly vertical, almost like consistently with a motor just running in a circle. I'm not going to go into like super details unless you guys have questions about that at the end. And then lastly, I worked at Tate. Tate is a company in themed entertainment. They design basically every concert stage for like the biggest stars in the industry. So when I interned there, I got the opportunity to work on stages for like Celine Dion, Drake, even Barbara Streisand, Queen and Adam Lambert, Jonas Brothers, a lot of really cool, big names, which was a lot of fun. But they also do work for staging in theme parks as well. So I got to work on some cool things there. As well as a good bit of like robotic systems as well. Sadly, I did sign an NDA, so I can't talk about the details of that stuff, but I can talk about some of it if you guys have questions. Next, I'm going to play a video about robot football. It's like 5 minutes long. Tell me if it's like way too loud or something on the share audio, but otherwise I'll give it a go. All right, cool. So that I think gives you gives me a perfect transition into my next slide. Kind of asking this question of like, what is a robot, and sort of what does that definition mean? And I think that's going to be important for how I frame the rest of the this session. So I'm just going to answer it with a classic Google definition, right? Any robot is a machine resembling a human being and able to replicate certain human movements and functions automatically. And so it was mentioned a couple of times in the video, right? In robot football, we're clearly trying to replicate the function of a quarterback passing the ball, or a wide receiver, catching it, or a kicker kicking the ball. I mean, that's kind of the focus. And like at the end there, he says as well, right? This is real football. It's just not humans playing it. So, that's kind of what we strive for. Obviously, they're much smaller and they're driving on wheels and not legs. I mean, the dream of the sport is to one day build our robots to the point that they are humanoid and sort of running around on the field playing football a little bit more like we know it today. So that's kind of the definition we're going to frame this in. And so I figured I would start off just by looking at some of the coolest robots, in my opinion, outside of themed entertainment first, just to help frame that definition a little better. So this robot here, this one's really cool. It's used for kids who have autism, and it really helps them with like their attention, right? They found that kids who had one of these robots to sort of like talk them through things and, sort of be with them as they move through life, like as they're growing up, right? They had like 70 to 90% attention rate, whereas kids without would have like a 3 to 10%. So, it's something that really makes an impact on a lot of kids' lives. Another really cool robot. This is like an exoskeleton robot. It sort of works with people who are recovering from, major like leg injuries. So robotics are used in the medical industry here, right, and helping people recover from, major trauma they may have encountered. Another really cool medical example of a robot are prosthetic limbs, and so right, using robotics to sort of rebuild an arm for a person who may have been born without it, or had some tragedy where they lost that limb. And the point of the grape in the picture is to show the dexterity of that robotic hand to the point where you could hold a grape without squishing it or dropping it, which is a major challenge. So really cool, another example of helping out people in that medical field. This little guy, he's basically like a BB-8, and he rolls around on a ball with a camera sort of on the front, vision, as well as like audio, like a microphone, and some other like a button or two, a couple light indicators. And basically the idea with this one is you can be like on vacation, let's say, and it's the classic, you have your Ring doorbell, somebody comes up to the door. The idea is that you can control this guy like a BB-8 droid, and he can drive around your house and turn on the camera and look in any direction you want to look. So a cool robot, just improving security in people's lives. This one, super awesome. Basically, you like give these robotic arms the instructions, and they go around and they cook a meal based on like certain instructions and like the ingredients you like set out in certain locations. It'll then go and actually make a meal for you, which is super cool. I could absolutely use that because I hate to cook, and that would be incredible. Another really cool one. So I'm the president of the curling team here at Notre Dame as well. And so there's this really cool robot they designed to throw curling stones. And it actually beat like a team of humans, which is sad to the humans, but also an incredible, engineering thing to put a robot on a field and throw some curling stones with it. I imagine many of you have seen the Boston Dynamics dogs, fondly known as Spot. This one is super cool. Basically, it looks exactly like a dog when it runs around, very fluid movement. I'm not really sure like what the purpose of it is, but it's just a really cool thing to have. I think they're selling them finally now after like years of development, but they're like $75,000 each. So definitely don't have that money, but really cool. Definitely would recommend looking up some videos about that one. And then there's this ASIMO. It's known as like one of the most powerful robots in the world, developed by Honda. But some of you might recognize him from a certain attraction at Disneyland. They brought in ASIMO to like the theming of Autopia a couple of years ago. And so I just thought that was a neat one. Really cool robot as well, capable of doing a lot of stuff. There's robots now too that can, read people's emotions via their like facial recognition software. Lots of really cool things out there. But I kind of want to dive into, what are robots in the themed entertainment space, right? Because that's kind of, what the session is about and what we're here for. So I'm sure many of you have heard the term animatronic, right? That's kind of like the core of robotics in this industry. And so the definition of an animatronic, right? It's the technique of making and operating lifelike robots, typically for use in film or other entertainment. So the point of an animatronic is really that keyword lifelike. You look at, like the ball security robot, right? Like, it doesn't look like it's that lifelike, it's just a big white sphere. But really animatronics, right? And I'm sure you've seen it, is bringing different characters, whether they're human, whether they're, animal, or some, sci-fi creation, bringing those things to life. And in our case for theme parks. So I went through, researched a ton on different animatronics. There's thousands of animatronics out there. So I kind of just like picked my three favorite to highlight for us. Abraham Lincoln, if you've watched like the Imagineering story, they talk on Disney Plus, they talk a lot about sort of that development. Built for the 1964 World's Fair at WED, the precursor to WDI or Imagineering, and literally blew people's minds when they found out that it was a robot up there, not a real human, to the point that they were throwing things on stage, right, to see if he would react when they threw their like, their cup or their hot dog or whatever it might be up at him. And, he didn't react because he's a robot. And it's just impressive. That's kind of where this whole idea of animatronics came from. Another one of the coolest animatronics out there, if you've been to Universal and been on the, I can't remember what it's called, but basically the King Kong ride in Orlando. And the animatronic there of Kong is incredible. And it was the first like animatronic to really build out to the scale. This thing is like the height of like 3 humans basically. And you go by and you're like at like nose level with it. So not only did they nailed the scale, but they really brought it to life, because it's easy to build something that big. But making it seem lifelike, which is that core of an animatronic, is really a challenge. And, you know, they nailed it with Kong, which is really cool. And then I totally butchered the subtitle on the third one. Looks like I forgot to edit that, but I'm sure many of you have, if not been to Animal Kingdom in Pandora, you've seen or heard of the Na'vi River Journey's animatronics. Now, the Na'vi River Journey doesn't have much to it other than this animatronic known as the Shaman of Songs. And basically, this animatronic has like the most lifelike facial features that we've ever seen in a robot. And so it's incredible if you, again, watch the Imagineering story. They have a whole scene where they show a person on the right sort of talking, and they're tracking all of the like facial muscle movement. And then almost immediately following, this animatronic is perfectly matching all of that facial recognition. And I believe they said there's around like 40 plus motors in the face of this animatronic alone. So like on our robot football players, there's maybe 5 at most, maybe 6. And this thing has 40 only in the face. So that just shows the, you know, complexity that themed entertainment really takes these robots to in order to achieve that whole keyword lifelike in these animatronics. Now there's tons of like other incredible animatronics. Sorry if your favorites did not make the list, but I'm going to jump next to in rides, right? So it's become kind of a popular thing ever since really Harry Potter and Forbidden Journey pulled it off. But taking these industrial robots that are normally used for, you know, the manufacturing of cars on like a plant in Detroit, Michigan, right, for Ford. And rather than putting, you know, a piece of machinery on it to then click into a car, you know, we're sticking humans on it and swinging them around, because what else would we do in themed entertainment? So I just figured I would show this video for those of you who might not have seen one of these. But basically, it's on this thing called a KUKA arm, which is the robotic like industrial arm made from Germany. And then there are like themed entertainment companies whose like sole like purpose is to take KUKA arms and then make like rides out of them. Super cool. And then also, if you don't know what IAAPA is, basically this is at a conference for themed entertainment. And because themed entertainment is this awesome, they literally bring rides to our conferences. So this is just a pitch to check out IAAPA. I believe it's still happening virtually this year, like 3rd week of November. So it's coming up soon. Definitely worth looking into. So you can imagine some of the possibilities. Oh, also, I've been doing a design project where we're making shopping carts. So apparently Google has started targeting my shopping cart needs. But just the complexity of the motion you get here is nothing that could have been achieved by, you know, a simple track on even a roller coaster or a dark ride. You get what would be called, in this case, 6 axes of motion, which means that you can move like to the left and right, forward and backwards, and up and down, but you can also rotate left and right, rotate up and down, and rotate like forward and back. So really cool. It gives, you know, the designers of the ride flexibility to do almost anything they want with the riders at the end of the robotic arm. So super cool. I'm not gonna watch to the point where we all get sick here. Oh my God, chat messages. Oh, cool. Yeah, so that is super cool. Oh my goodness, this is so slow. So definitely worth checking out. There's lots of videos out there and lots of different rides to sort of like look into. Now just imagine that arm on a track and sort of like driving along and taking you through a ride. And that's how a lot of like theme park rides sort of pull off really cool experiences and sort of telling that story as you move through. Robotics in parks. So there's this really cool, I hadn't found out about it until I was preparing this presentation, but in South Korea, they're building a theme park solely dedicated around robots. Construction, they basically cleared all the land, which is cool. Construction starts in 2022, I believe, and the park is projected to open in 24. But you can see in this little like concept map they have here, there's like the Robot Kingdom, Robotopia, Kidbot Village, and then just Fun City. And I mean, I'm a fan of Fun City. I'm not sure how well it fits into the theme of robots, but it looks really cool. And I just thought it was super unique. We've got, you know, animatronics, we've got rides, and the first ever robot themed theme park coming to South Korea soon. So that's a kind of random note, but a cool little piece of theme park news coming up. Looking then sort of into the future, right? Like robots are continuing to become more and more involved in all sorts of different industries. Like I talked about in the beginning, right? You have, you know, culinary robots who are now cooking meals for people. You have medical robots who are building up like, you know, new techniques that weren't able to be achieved before and like saving people's lives in ways as well. And so this idea is, how are robots going to continue to sort of build our world in the future? And then particularly, how are they going to impact the themed entertainment industry as we move forward, especially post-COVID? So I put down 3 that I think are going to have an impact because I think these are incredible. So the first one is the service robot. I imagine most of you have seen these at Lowe's. I've seen them at Walmart. They basically just kind of like float around. And if you have a question, right, like you can go up to and talk to this like robot thing, and it'll like help you answer the question. And I believe they also like clean the floor as they walk too, which could be super cool. So my idea was we take these robots and have them basically be like roaming park maps while also cleaning like the floors in the theme park and like picking up trash. So, you know, it could be a really cool way to greet guests at the entrance. If any of you read Kingdom Keepers, it would be like the holograms that walk people through the park. Just you do it with the robots, and it sort of like takes them, hey, walk me to Space Mountain, and then it walks with them to Space Mountain. So not sure how all the logistics would shake out, but I think it'd be pretty cool. The second, this is one that, you know, obviously sort of exists in themed entertainment already / almost soon. If you don't know what this image is, it's also my background because I think it's so cool. And we'll watch a video on it on the next slide. But Imagineering has been developing robotic stunt actors who will be able to do things that sometimes we see in the movies, you know, that they pull off with wires or, you know, green screen, CGI, whatever it may be, that like a human stunt actor just can't really do, you know, or maybe the risk is too high. With robotics, right, we can make it very lifelike and sort of bring them into a human function and say, hey, go do what a superhero would do, go do a flip, or here a Superman pose. And then that'll help us tell our stories better because it'll be a lot more believable as opposed to a human who's going to be limited by what obviously humans can do. And then this third one, I don't know, I did not know this existed, but I sort of, as I was just looking around, found this thing that somebody built. And their idea was they just wanted to make a transformer that they had always, you know, watched growing up as a kid. And they wanted to actually make it real. And so this thing actually sits 2 people, and then it actually transforms from a car into like this, you know, the classic like 2-legged robotic thing. And I just think that would be such a cool theme park ride. And we'll watch the video and it'll make more sense. So I'm going to start with the animatronic stunt actor here first. We'll play through this video, and hopefully if you haven't seen it, this will be pretty cool stuff. Come on, buddy. All right, so that was that. I think that video gives me goosebumps every time. It's so amazing. And then we're gonna check out this transforming video as well, just to give you a better sense of like how this thing actually works. So those are two real humans sitting in the driver's seat and the passenger seat there. This one doesn't have quite as epic of music, sadly, to cover for me, but just imagine if this were a theme park ride and you got to sit in the cockpit there, and all of a sudden, like your ride vehicle, because this car like is able to drive, I believe, all of a sudden just lifts off the ground. I'm gonna play it at like a faster speed because I forgot how slow this is. So at 2 times speed, it's pretty cool. So all I'm saying is future of themed entertainment is transforming ride vehicles, where, you know, 1 minute you're on just like a normal dark ride, and then boom, all of a sudden your robot is like running through the ride. That'd be pretty insane. So yeah, that's most of what I had. I think that covered like 30 minutes or so, which is what I was shooting for. What I'd love to do now is break people out into, we can probably do just like 2 breakout rooms, and just take like 5 to 10 minutes. And let's just, I want you to each think sort of like in your groups, at a theme park, any theme park, any experience, kind of like grounded at a specific place though. And then think of like, where could a robotic implementation take that guest experience to a new level? I gave you 3 examples of, you know, my own thought on how robots can sort of step things up. So Caitlin, if you can set up those breakout rooms.
I don't have access to breakout rooms right now.
Oh, do I need to? Okay, I can set them up. I'll just assign automatically. All right, go ahead and go for it. Hop into your breakout room, and then I'll send a message once it's time to come back. Welcome back. Were there any ideas that like particularly like jumped out at any of you as like, you know, like we got to build this?
Yes, sorry, I'm like geeking out because Ariel just showed me that there's an animatronic Pascal like from Tangled, and I'm like dying. But anyways, we were.
It's so cute.
Is there a link?
Can you share your screen with it?
I'm on my work computer. Just literally look up animatronic Pascal.
I'll look it up.
It's so cute.
and then we'll actually discuss the ideas, priorities, right?
Also, those like Beauty and the Beast animatronics too. I don't know if y'all seen those.
Those are so cool.
It's so cool. The waltzing one.
He's so cute.
That's adorable.
I mean,
that is actually amazing.
The same kind of idea as a lot of those Beauty and the Beast animatronics, where it's just like ridiculously lifelike. But
and that's where, when I was making this slide, I literally changed, which one? This one? I literally changed the like animatronics I did, but I was like, they don't want to see me just list off like, you know, 40 animatronics, because like there's just so many that are so cool. So I tried like keeping it pretty quick and simple. But I haven't seen that Pascal one, so that one's actually pretty cool.
One of my favorites is not, oh, sorry.
No, go for it, Caitlin.
Oh, I was just saying one of my favorites. It's not necessarily from theme parks, but the T-Rex from Jurassic Park, which I believe is inspired by the animatronic for the original Kong ride Confrontation in Universal Studios. Always super, super cool. It's amazing how much the special effects in that film like really hold up, even to now. It's like almost 30 years ago. And that's like a huge part because of how often they implement animatronics as practical effects. So yeah, those ones are always super cool.
Absolutely. Yeah, how Jurassic Park has held up over time is actually so fascinating.
Yeah.
What were you saying though, Danielle? An idea that blew you away?
Oh, well, the Pascal blew me away. But our idea overall was just thinking about how to incorporate animatronics in a more subtle way, particularly in character interactions. Because we were thinking, like, for instance, like with Mike Wazowski, like he's such an odd body type, and it would be great if he could actually like articulate his arms and like sign an autograph or something. Or even thinking about like Wreck-It Ralph, his hands are always clenched in a fist. And just being able to articulate that, like that could also be done in other ways. But yeah, we were just thinking about like how do you augment certain character interactions, particularly, yeah, again, like with body types that might not necessarily match to human proportions, and that could be really cool.
Yeah. Caitlin, did you have something? Oh, go for it.
Oh, I was just going to say, I'm trying to find this image that I took a photo with like WALL-E.
If you saw, yeah, I snuck him into the last slide because I was
but there was like
WALL-E.
There was like this thing called Maker Faire in the California Bay Area, and they had like a WALL-E around. This was like a long time ago, but he was really cool, and like his head his head moved, and he like looked at me and like kind of moved around. So
have you seen the Pixar in real life shorts on Disney Plus?
No.
Because they have an episode with that. I don't know if it's the exact same one, but like it looks a lot like that WALL-E animatronic. I would highly recommend. Super entertaining. Basically, they like take this animatronic WALL-E on the streets of New York and prank a bunch of people with them, and it's so like so.
That's not a prank. That's just like, please come and live with me, WALL-E. But
I will say an idea that I really enjoyed was Caitlin had the idea of taking like a flying coaster, right? And then if you themed it to like a dragon or something, you could put like robotic wings on the coaster that actually like flap with the ride. So like as you're flying, it's almost like you're being like carried. Like the way I imagine it is you take a Lord of the Rings theme park, which still hasn't been built yet. So hoping I get the chance to work on that maybe one day. And then the classic eagles, like you have the whole scene where they hop off the cliff and the eagles just like save them all from the orcs. And then like you're soaring with the eagles, like just imagine like the eagle wings like flapping above you as they're like flying you to Mordor. But then apparently you can't fly to Mordor. Not going to talk about that whole plot hole, but those who know. But I thought that was a great idea from Caitlin, and I think Ellie had a really good idea too of like bringing them into the museum space a bit more, and really like using them to engage like education and learning more than maybe eagle wings on a roller coaster do.
Yeah, I know the Smithsonian had like a robot named Pepper that looked sort of like, I forgot the name that you had, the one from Honda looks like similar like that, but it was just kind of like could only do really minimal interactions, also because museums don't really have money. But yeah, that's a great idea, Ellie.
This isn't like something futuristic or like new and innovative, but I remember when I was a kid at Animal Kingdom, they had this robot that was a trash can. And like, yeah, and it would talk to you. And I'm sure it was like someone in the back just talking through the trash can. But like, that was the weirdest thing to childhood be. And I wanted to go to Animal Kingdom just for this talking trash can. And so like thinking of strange stuff like that, that's maybe out of the box might be a good way to go.
Yeah, we were talking about that in our breakout room. I think his name was Push, the talking trash can, if I remember that correctly.
Land and Disneyland too.
Yeah. We're just talking about like just walk around characters in places like Tomorrowland, Galaxy's Edge, kind of like futuristic theme, just to kind of like make it more immersive in that sense.
I I think that's like what Shannon had mentioned in our group as well, was the idea of like waiters, like possibly like in Galaxy's Edge or like the Star Wars hotel cruise experience or whatever, like C-3PO like walks up to you and like gives you your meal. Like that would just be so cool. Or like if any of you watched Lego Masters, when they designed like the Lego like waiter who like brings them their food and he's like about to drop it at a very moment. I don't know if you remember that specific episode and that specific build, but I loved it. And so yeah, definitely would love to have like droids come and like give me my food at a restaurant.
Speaking of hotel robots, I watched a YouTube video once and they were going over like interesting hotel designs. And there was one, I think that was in Japan, where all of the service interactions, so like the front desk and everything, were all run by robots, but they weren't necessarily humanoid robots. Like I think one was like a velociraptor robot. And so you just like walk in and like sitting behind the desk is a velociraptor and like that's who you check in with. And it was like they were just all around the hotel like this.
That's actually so funny.
I'll see if I can find a link to it.
Also, just thinking off the top of my head, like maybe using robotics more for safety purposes. Like I don't know how, like I like launching fireworks or like preloading them and checking and making sure. Like I know that there are humans who are like super trained and qualified to do that, but maybe just augmenting that with like robotics could be interesting.
Yeah, that's a really interesting one. And another one that kind of comes to my mind if, again, you watch like Disney Plus a lot, which like I feel like that's all I ever do. But they do the shorts where it's like a day, what do they call it? A day in the life of Disney or something like that.
One day at Disney.
Yep. And there's like the guy who goes and like is basically like the underwater welder who like goes and like checks all of like the piping to make sure. Like imagine if you didn't have to be like putting humans like through all the training required to do that. You could just have like some robot that just goes and like you drop it and it just like from Incredibles, you know, the one that like scans through like looking for Mr. Incredible to check if he's dead or not, like something like that that's just looking for like, you know, like you said, safety, like any fractures in any of the like elements on a ride, like because that's tedious work that humans are like prone to like mess up on and like miss something, whereas like that robot will just do it like for, you know, year after year.
It kind of reminds me, you know, like the cleaning robot from WALL-E. I forget his name.
Oh.
But like, yeah, like something like that would go around the park and like pick up trash and stuff like that, you know, spilled popcorn, those types of things.
Yeah, I will say I was the human who had to do that for a bunch of years in a theme park, so I would love to have robots do that for us. Here, I'm gonna share Caitlin's video so we can all watch it.
I haven't listened to it, just FYI. I just saw the...
No worries.
Welcome to the Henel Hotel. If you want to check in, please press 1.
I love the dinosaurs at the front desk. That's the best. Good stuff. Any other ideas that people had on, you know, robotics?
Oh, new idea. I know that the I can't remember what their title is, but the people who like come in and make all the beds for each of the rooms in the hotels, I know
Like
that
room
they,
service,
yeah, I know
house
that
cleaning. That's what-
they usually, the way that they do it is that they have like a certain amount of time that they have in order to like clean, make the beds, do all of that for each room. So either maybe having like a robot assistant or having that all be done automatically, like would probably save like just a lot of energy, because I know that that's like a really, that they're always under a lot of pressure to be able to go through, clean each of the rooms in like 2 minutes each and then come back out. So
And it probably could help them do it more, thoroughly as well then, because they're less like pressured to like skip something.
right. And also just being able to like automate, like, oh, this one's in this room, this one's in this room, and you can kind of have a like an automated log of how that's being done.
A couple of years ago, I did like a human-centered design project on theme park restaurants, and like one of the pain points that was like really like one of the major ones was efficiency for theme park restaurants, and so you showed that like robot that could cook. So especially since for the most part they're very repetitive meals and fairly easy, that could definitely help speed things up.
That'd be so cool. And I feel like too, like any park that did that would like flaunt it almost as like an attraction somehow. So you like wait in line to watch the robot cook your food or whatever, and then like people would line up for it, like without a doubt.
I like used the stuff that the data I gathered to design a restaurant like that it addresses everything. So I didn't Meet the Robinsons themed, and I definitely had a Carl robot in there. So I think that would be super fun to make them all themed to characters.
Yeah, that would be so cool.
From the Muppets and like just really random stuff, Ratatouille, all the things.
I mean, I just want that at like, a restaurant like in town near me, so I don't have to like go to the park, so I can just like hang out there every night. But sadly these things cost like a lot of money. That's like one thing I barely touched on. Like I said, the Boston Dynamics dog you can buy for like 75. If any of you watch like Dude Perfect, also they had an episode where they like bought one and were like playing with it on like, they're like YouTubers basically, and they were like, yeah, this cost us like $75,000. And I'm just like, what? That's so expensive, but it's literally so cool. But like our robot, like football players, cost maybe like $1,000 to build, which is like not cheap, but 75 of them is the cost of that Boston Dynamics dog. So I just always wonder, like how much more do some of these like Disney, like WDI R&D projects go to like design this guy over my shoulder here.
So do you think it's like particularly expensive just because of the amount of expertise that it goes into creating each one? And also because I would think the individual components might not cost that much unless they're custom fabricated.
Yeah, I think part of it is the expertise, but also like the components that are needed. Like I think what you'll find is, at least in my experience with like actually like doing robotics, like I'm working on a running back design right now. Like I literally had a design review earlier today. And what we're doing on this one is we were like, okay, our motors are like a certain one that we buy, and they're like $60 a motor. But we realized they were like burning out, like they get too hot too fast. They don't have as high ratings of like torque and speed. So like they're just slower. And so we're like, okay, well, can we find a better option that runs on a 24-volt system, right? A bunch of design constraints, just imagine, get thrown on. And we found like these really incredible motors that like hit all of our like constraints perfectly, but they cost $600 per motor. So they're 10 times more expensive. And they're like made in like Switzerland or something like that. But they just do everything like so much better. And so what you find is that like in order to pack really high performance electronics into really small spaces, the cost just goes up exponentially. So my guess is on that Boston Dynamics dog, there's like a ton of sensors that are like, because man, I should show a video of it, but like if you like kick the, like I would never do this, just as a like disclaimer, but if you kick like the dog or like push it over, or like it runs into a person walking, like it'll like get hit and it'll like catch itself like a dog would and like stand back up. So like it has like some insane like electronics in it to sense like its exact position of all of its limbs in order to make the adjustments to catch itself and like readjust. And so to put those into such a small space, I think the parts are like a lot more expensive than we realize. Now, I'm sure they're also turning a very good profit on that $75,000. So I doubt they're selling it at cost, but that's kind of what I would say is probably how it looks. But
I feel like it's one of those things where it's like individually those parts cost a lot, but like just like with everything else, as you buy in like bulk, if you're producing at scale, the cost would go down. So like to incorporate more robots in theme parks, like the ones we've been talking about, especially ones that would replace humans, it would end up being cheaper because like if we're doing the character meet and greets, a lot of those actors are equity, which are already super expensive. And like you have all the unions to deal with, which causes all sorts of stuff. Or like, you know, you have to pay hazard pay for certain jobs and things like that. So even if the robots would be pretty expensive to buy, overall the labor cost would probably even it out relatively quickly.
Yeah, no, that's actually a really good point. I mean, what are you paying for a charge? Like some electricity bills, and then the occasional like maintenance worker and like the, you know, parts he needs to buy. So that's actually a good way of looking at it. What were you going to say, Danielle?
I was going to say, like, isn't there a thing like I'm looking at Moore's law, like where you can pack like basically transistors will like decrease in half like each year. So I'm just wondering if that's sort of the same thing that's happening with robotics, almost like high efficiency parts become cheaper and cheaper the more and more you make them.
Yeah. And I think like the Moore's law is actually super interesting. For those of you who don't know, the idea basically is that like electronics every year, like for the past, what's like 20 years or something like that, have gone like half as big. So it's like the whole idea of like where you needed a flash drive like 10 years ago to fit like 1 gigabyte. And now we have like a flash drive the same size that can fit like a terabyte. So that's like, I don't think those numbers are actually real, so don't like quote me on that, but that basic idea. And so the like really interesting thing is like, will that continue into the future? And like, when do we sort of hit like the ceiling on that? Because I don't think we're going to exponentially do that forever. Like that's not physically possible. So there's going to be some place where we like plateau. And I just hope we don't plateau for a really long time. But no, that's a good point though. You're totally right. Like as we continue to develop technologies in other spaces, like these robotics are going to be a lot cheaper and easier to manufacture, as well as things like 3D printing becoming, like additive manufacturing becoming more feasible. Like I don't know how, like what materials they did this guy over my shoulder out of, but it's like some fascinating, like flexible, probably some like composite, like polymer plastic material that's able to bend and fly. I don't know. It's so fascinating, but like that type of material selection didn't exist like 10 years ago. And so you wouldn't have had, you know, that clean of motion because you didn't have the materials to pull it off. So I think you're totally right. Just as we continue to develop technologies on all fronts, you know, sort of this robot that brings them all together is just going to be so much better, you know, year after year. Cool. That's perfect. Great discussion. That's what I was hoping for. I was like, I'm just going to hope they bite on the discussion hook. And I think it went well. So any other questions on robotics that are still floating out there?
Actually, I have one question. So as far as theme parks go, I don't know how much this goes into robotics, but they have to run them almost constantly every day. So how much does that kind of factor into kind of what we're talking about with like cost and maintenance and all that?
Yes, I think a lot of it really depends on battery life, which is obviously critical in that whole situation. And so, I mean, we've gotten to the point where there are some incredible battery life that like we're able to produce, like a Tesla being able to drive like 300 miles on like one charge, which is incredible. It's obviously a factor of like, when you're saying maintenance, how complex the robot is, right? And generally we look at it like axes of motion. Like I was saying, like a normal like defensive lineman on the robot football team has 2 motors, 2 axes of motion basically that just spin. So he doesn't need a lot of maintenance normally, unless like he's actually in the game and getting hit, because they get like 25-mile-per-hour like head-on collisions, which is like you saw the quarterback just snap in half on that one play, which is so sad. So I think it's a matter of like what use case we put them into. That'll define how much maintenance they need. Like, is this something that the guests are going to be like touching and interacting with? Because obviously, you have those safety questions, like we were saying, character meet and greets. Like, you have to like expect like the dumbest possible behavior of a person who's going to start just like ranking on Mike Wazowski's arm trying to pull it out, which could then lead to like terrible maintenance costs, because people are now all of a sudden like tearing arms off of your very expensive animatronics. And so like there's some of those questions, but if it's something that's maybe like the cooking one behind the scenes that's just running in like an enclosed, very controlled environment, you'd probably need like almost no maintenance. You'd just be running like the cost of electricity to just power that thing continuously. There's also really cool like wireless charging that's possible. And so like you can literally have, like, say you had a character meet and greet, if he was standing on a certain like platform basically in the park, it could literally be charging while it's just like standing on that platform through like wireless charging, which is the coolest technology ever. So like it's the way, what's the new, is it Luigi's Rollickin' Roadsters at DCA now? If anyone knows of that ride, it's like, it used to be the flying tires, like floating ride. Now it's like these things. But what's fascinating about that ride is there's like 30 little ride vehicles that run around. They do like a dance as you sit in them, and it's like Luigi's family or something is dancing. But there's like 2 charging pads on the actual like flat ride. And so what they do is they sort of shuffle and they like move around, and after every ride, like a different one lands on the charging pad. And so they have it timed out where like, say like I get on the ride, I ride it, I'm on the charging pad, I'll end up my ride vehicle not on the charging pad at the end of the ride, but like Caitlin's ends up on the charging pad. And then while they're unloading and reloading, hers is like building up its, capacity on its battery, and then shuffles. And then, Ariel's lands on the charging pad next and starts like recharging. So that's like technology that's used in like rides as well. That's not as much like robotics specifically, but sort of that wireless charging tech could be a really good way to get around this idea of like battery life. It is less efficient though, so you're spending more electricity and you're losing a lot of it to the environment. So it does cost more in that sense. I don't know if that really answered your question, but it might have.
Yeah, that was really good. Thanks.
Okay, cool.
I guess sort of building on and asking another question, like what about like indoor robotics versus outdoor? Because definitely the elements are going to take a toll, especially like Florida with all the humidity.
Yep. Yeah, so it's funny because we joke about that in the robot football team, because like we can't really take our robots outside because our electronics are all basically exposed. And so the difference is like, basically the only thing that's going to be affected by, not the only thing, but the main thing that'll be affected by weather are your electronics, right? Like if you all of a sudden get rain or like moisture into your electronics, you're going to be shorting, you could be potentially shorting some circuit, which will fry very expensive electronics like we talked about. So that's the downside to weather. But I mean, there's really powerful material choices and like manufacturing processes that can ensure that those are completely like enclosed in waterproofed spaces, right? So yes, outdoor robotics are certainly like plausible, feasible. I was about to combine those 2 words. But it takes like a whole nother level of like design and engineering and like really high quality, which then is going to drive up your costs. Whereas if it's indoors, it's a lot easier because you're sort of dealing with controlled temperatures, controlled what's it called? Like humidity, moisture. So we joke in robot football because we're in Notre Dame that like we want to play in a snow game with our robots and just like put like snow plows on the front of all of them and then like battle another team with like snow plows. But the rest of my team is not on board with this idea of putting our robots out in a snowstorm. So I just got to convince them. I don't know if that helped answer. Again, like I'm just a senior in college. Like I've done a lot of robotics, but like I have a lot to learn myself as well. So definitely would highly suggest like Google and Reddit, because like there are some genius people on Reddit who I don't know why they spend their time on Reddit with how smart they are, but they do. And it's kind of hilarious to me that like people are that smart and also spend their time on Reddit, because I feel like I spend too much time on Reddit, but that's a whole rabbit hole. Cool. Any other questions? All right. Well, great stuff. Thank you to everybody for coming out tonight. I had a lot of fun. I hope you guys did too. I hope you got to see some cool new animatronics that you never really saw before and had a chance to sort of flex some creative muscles and balancing that with the technical side of robotics. So we'll have a session 2 weeks again. So next week's an off week. Keep an eye out. What is it, like November 7th or something like that? And we'll keep you posted on who's going to be speaking later next week. Awesome. All right, everyone, have a great night. We'll see you around.
Thanks, Jake.
Thanks.
Thank you.
This is fun.
Are you
Good
in?
stuff. All right, I'm gonna go head on up to Hesburgh, I guess. Are you
All right.
coming?
I'll be coming around 9. I
Sure.
got to figure out some CAD stuff. We'll see.
Cat?
CAD.
You're getting a cat. What kind?
No,
Tabby?
no. CAD.
Hairless? No, I'm joking. I'm joking.
I don't know. This
Come on,
is like
you can't buy my crap, Kaylin. You've known me for too long.
I after the tabby, I realized you were joking.
Oh man. For your drone, you're saying?
Yeah, I don't know how to make it go vertical is the problem. Like how to build up vertically.
What do you mean?
Here, I can show you. So like the dragon head needs to go up here-ish.
Yeah.
Right? And this is what this is what currently exists. Basically, the red stuff hasn't been printed yet, but all the green has.
Tinkercad.
Tinkercad, yeah, that's what our professor's having us use.
Okay. So
I
wait,
will
the
say-
green is done.
The green is printed, and then everything in this middle area is printed. It's just like
Okay.
this red that's not. And
Okay.
so this is not printed. That's an idea. But basically, the head needs to be up here, and the body needs to come here, and one leg goes here, and one leg goes there.
Wait,
And then a
the
tail.
one leg thing was too fast. Your
So
like,
the
mouse
head-
just like spun in a circle.
Sorry. The head is here,
Yep.
right? The body comes down like this, like it's laying on
Mhm.
this stack of gold bars. It's what it's going to be on the outside.
Yep.
And then one leg is going to be over this wheel, and one
Oh,
leg
got
is
it.
going to be over this wheel.
Got it. And you're trying to figure out how to actually mount your head.
Yeah, like how do I, because like cardboard is what's going to be going in between these supports.
Wait. Oh, cardboard?
Yeah, because he doesn't want us to use that much PLA.
Oh, that's fine.
Yeah, so I have to like build something up here to like
So-
hold the cardboard domed.
Yep. That's not
And
too
then-
hard.
Well, I guess like the cardboard will support itself, like when it's
Yeah.
tense.
I mean, using the cardboard is lame. What's the scale of this thing? Like length by width?
I'll just tell you the actual dimensions. This
Oh,
is
are you in?
millimeters?
No, Caitlin.
It's not a choice. We were
Inches.
told.
Inches.
No, wait, no. The metric system is so much better.
No.
Yes.
What is 350 millimeters? Go.
In the customary system?
No, just what is it?
Huh? It's like, what are you talking? I don't understand the question.
Yeah, because you don't understand what 350 millimeters even is.
No, I don't understand what you're asking.
I'm asking you what is 350 millimeters?
Huh? It's like 0.3 meters. So about a foot?
Oh, what did you just say?
A foot.
A
Because
foot.
I'm trying to explain it to someone who
Oh.
only understands the
No,
customary system.
Because you don't understand metric unless you convert it into imperial.
Because I was born into a country that uses customary. That doesn't mean I think it's better.
What if I told you that that was 13 inches long? Then you'd be like, oh yeah, I know what 13 inches is.
Of course, because I was born here, but just because
So
I
why
understand
are
it
you
doesn't
using
mean
metric.
because the professor told us we had to. That's
So
why
your
I'm
professor is
using
A,
it.
wrong.
Huh? So
designed
that's
it all in inches and then changed to metric on the last day.
Why would I do that? That's just more work.
It's literally not more work. It's literally less work because you don't have to convert from metric to freedom units in order to understand what you're even designing.
Freedom units?
That's
I understand what I'm designing because I have a mental, that's, okay. Maybe this is, I have a mental image of how big this is.
Oh, wow.
I wasn't, shots fired, but it's true. Like I can mentally imagine, I don't need to know the conversion rates.
But like,
I don't convert this to customary in my head.
Inches
are so bad.
No, they're literally so much better. How much is 1 millimeter?
Just because in order to quantify it, I have to convert it to customary doesn't mean it's better.
Like, name something that's 1 millimeter.
Huh?
Like,
again, I grew up in customary. This is not a fair question.
1 inch, this knuckle. 1 foot.
That's okay.
From here to here.
But that's on an average, like, that's not everyone. Like, our forearms are different lengths.
Yeah, but like, but our knuckles are not so different that yours is like 1/2 inch and mine is 1.5 inches.
Right.
Knuckles are going to have a difference in tolerance of like maybe 0.2 inches.
So, but regardless, it's an estimation. I don't understand.
But I know what an inch is.
Mm-hmm.
Like, I know what like 5 pounds feels like, or like I know what a pound is, right? It's like a stick of butter.
Right, but if you grew up in kilograms, you would know what a kilogram feels like.
I really don't think so. I've talked with there are fellow engineers in my class who are from like other countries, and they're like, they don't even know what like kilograms necessarily are. I mean, like they know like what
their weight is done in kilograms.
Yeah, I know, but they're not like, oh yeah, that would be like this many kilograms, because it's just not an intuitive system. It's great for unit conversion if you're trying to do like complicated scientific studies. But if you want to actually use the units, freedom units all the way.
You just have to learn how to use them.
No, I literally have learned how to use them, and they're less effective.
Because you convert them to customary.
No, they're less intuitive.
But you don't think they could be less intuitive because you originally learned
What does 212
customary?
degrees Celsius mean to you?
Absolutely
Or
nothing.
fair. Yeah, exactly. But like what does 100 mean?
Because we've learned it. I haven't learned Celsius.
But like, what is 100? 100 is, man, it's really hot outside.
Yeah.
0 is, man, it's really cold outside. You go to Celsius, 37 is really hot outside.
If it's above 0, it's warm. If it's below
Like
0,
0
it's not.
is like, it's not really that cold.
Well, that's because you choose to wear shorts when it's above 32.
But also, it's not that cold at 32.
It is cold.
No, it's really not. Freedom units. Also, I'll actually help you if you want to share your screen again. But I mean,
Sure.
That's probably your main problem with mounting this head, honestly.
That's my units. Well, you can take it up with Professor McLaughlin.
What does this head need to actually mount to?
So,
like, you just have
basically,
random gears floating around right now. Like, how are you actually going to mount to the head?
So, my thought was there's going to be a pole. So that's why I had this pole here.
Okay, but like, how is it connecting? You know what I mean? Like, you just have
it's
a
just
gear
setting on
floating
top.
around.
Yeah, so that gear is going to be attached to a servo motor. So this is going to set kind of like that, and then this is going to have a ledge that comes out, and the servo motor is going to sit on that and attach to this gear.
And that's hidden under the cardboard?
Yeah, so then the idea is like the
and
cardboard
that servo
comes
motor
out
lifts
here.
the dragon's head or his like mouth off the bottom?
It drops the jaw.
Okay, so the jaw has not been designed yet, but that head you want to stay perfectly stationary at all times.
Yes, the jaw has been designed. The jaw is all in here with the gear.
Oh, okay. Oh. Do I just not see? Oh, it's tucked inside.
Yeah. You see the teeth?
Understood, yeah. So, I mean, how is your dragon's neck going to look? Like, is it a perfectly straight drop neck, or is it like a curved neck? Because I think you need to think about that before dropping a perfectly vertical pole.
Right. So the ideal situation is that it comes out, goes back in, and curves up, right? Like the chest is over here.
Yep.
And then, so this hole needs to be open, but it goes like this. But it's supposed to be a robotic dragon, so I can feasibly make it more angular and like make it still like make sense within the context of a
geometric dragon. Yeah.
Yeah. And I think that will be easier given the limited amount of PLA that I have and the fact that I have to use cardboard.
It's going to be really hard to do that, like curved in and out and in and out with cardboard.
Right. So then my thought is like, I could have something sticking out here that has another one of these, right? And these are made to like hold the cardboard in place. So, but it's kind of hard. So the thing is that the exterior has to be removable. Like you have to be able to take it off, but the head needs to stay attached.
Wait, why?
Because it has wiring going into it, and he doesn't want you to remove any wiring when you take off the exterior.
Oh.
Yeah.
These are very random rules he's arbitrarily assigning.
Yeah.
So the head is going to have to stay like mounted to the chassis while you take the shell off.
Yes.
How are you mounting these green things to each other right now?
PLA glue.
What? Okay.
Why? Wait, what was that reaction?
I mean, is that holding up any like forces or structure?
Yeah, it's like, well, so our professor says that the glue we're using, like when you glue two pieces of PLA together with it, that joint is stronger than the PLA itself.
Okay.
Because of like how the glue bonds it.
Okay. The stuff I've used is not very strong. So, I mean, I hope it's a very different thing than I've used. And I assume that it will be. But as to mounting the head, I mean, rotate around it. Like, what other methods do you have? Like, are you allowed to use bolts and nuts? What kind of strategies do you have available?
We have PLA, Velcro. I mean, we have screws, but like, and like this is wood, but like this is PLA right here. So like you can't screw through the.
Well, yeah, not screws. I'm saying like bolts. You know the difference?
Yeah, I know the difference.
Okay.
We have one bolt. I think we have one bolt. Yeah.
Wait, like
I don't know what it's for yet. Like he gave us
one specific bolt.
Yeah, like he gave
one
us
type of bolt.
No. Like I've seen one bolt, and that's it in our kit. So like I could probably ask him for more, but I don't think we're necessarily supposed to use them.
And that top head is like PLA, and that post is PLA.
Yeah.
I mean, so your thought is just to PLA glue that thing on?
Yeah.
I mean, I think that would work, honestly.
Yeah, but then the question is like, what do I build? Like, how do I get the exterior, like the neck, to go around that?
What do you mean?
Guess I could have like, because like, if it comes straight off the top.
Oh, the neck has to come off with it?
I guess it doesn't have to.
So I don't know if I fully understand this whole idea of having to take certain things off.
So basically, in order for him to grade it,
the electronics.
He needs to see the electronics.
And you're worried like the neck is covering the wiring heading up or running up to the head, basically.
Yeah. But if I don't actually glue the cardboard in and I just like take one panel of it and just set it in, like, and I like put enough tension on it,
yeah,
I should be able to just pop that out and let him see it.
Yep.
Or the alternative is that I could build it so that the left half or the right half comes off this way and the left half comes off this way, but like with how my base is done, that's not really.
What I would, you can't use PLA. That's so dumb.
Can't use what?
PLA for your like body.
Oh, yeah. Yeah.
Because what I would advise, now this might still work in some way you can get to work, but I assume you know what a snap fit is.
Mm.
Like, you know what a snap fit is. Basically like any like battery compartment on a remote, you know, you like kind of slide one end in and then like you push it down and the plastic kind of like bends and then it snaps into place.
Yeah.
And then you can't pull it back open until you sort of like compress the piece and then you can pull it out and then it like springs back open. But there's no like springs. It's just done with like the elastic deformation of the like plastic material. So the upside, what I was imagining with that was like you could basically like make like two pieces out of PLA and then like snap fit them together as the neck that would snap on. Then you can just like squeeze it and separate the neck when it's degrade.
That would be interesting.
But if you have to do it with cardboard.
But if I could just get the frame to snap together.
That's what I was gonna say. You might be able to find a way to do, yeah, like a frame that the cardboard then like glues to. I will say snap fits are difficult to do well.
Mm-hmm.
So you would want to make sure you do your research on like the actual like I know SolidWorks has like a very good like snap fit feature you can use. I don't know that Tinkercad would have that, so you'd probably need to like Google like, oh, how tall should it be, how wide. Usually they have like a taper to them. So I don't know if you want to go that route. The like less quality option behind that is using a press fit, which I assume you know what a press fit means. Hopefully not. Okay.
No. But wait, instead of doing a fit like that, what if I just had where one end, like, so let's say you have two halves that would theoretically snap together. What if instead on one I put like, think like a basketball hoop, like a tiny basketball hoop on either side, and then the other one I made two posts coming off so that they just slipped in together.
Oh, you're saying like it'll just be two rings that align and then you drop like a pin through them?
Yeah, or not even a ring, like just one ring and then the other one has a hook. So basically like a hook and loop.
I mean, that could work, yeah. It's the question is, that's going to be a lot more likely to come apart is the problem with it. Now, if you can do something where like you can do threads on the 3D printer, like they're going to be really low quality, but like if you put some sort of threads on it, you could put a nut over the top and that would lock it into place so it wouldn't be able to slide off, if that makes sense. So like generally like as a mechie, you don't want to just have like loose connections floating around. So the idea of the snap fit is you don't have to add any additional hardware. It like would slide into the ring and then it would like grab on so you couldn't pull it back out easily. The other option is like a press fit that just uses like friction. So it would be like, imagine your ring with like a cylinder idea, but it just like is designed so they're just perfectly tolerant that they like slide in together. But the friction is enough that it's really hard to pull it out. Like if you want to take it out, you can take it out with all your might, but like any normal force isn't going to take that press fit out.
Okay. And I don't think it has to do with a lot, like the worst terrain that we're going to have this on is like carpet in Duncan. So
you're fine.
Yeah.
you won't need to account for major forces. I just, the cylinder in a loop is not, like I could definitely see that coming apart even on carpet in Duncan, unless you find a way to like maybe you curve this cylindrical shape so that the like hoop kind of like wraps around it. That would help like reduce the chance of it coming out. But I think that would be your best way of doing this neck is to do some sort of 3D printed piece that you then like glue or something. I don't know how you're mounting your cardboard at all. But however you then connect the cardboard to the PLA mount, you could then just like pop it apart and take it off on two pieces and then take the shell off.
Yeah. I think that might be the move.
I don't know, like, again, what all these restrictions are or the complexity of your thing. Like you have a bunch of random holes on things, but apparently you're not using bolts. So I have no clue why you have holes everywhere.
What holes? Oh, these are screws because this bottom platform is wood.
Oh, you're just using wood screws into that?
Yeah.
Okay.
For this stuff. And then like this stuff is like Velcroed on to the PLA.
Is that just electronics?
Yeah. So amp. Arduino.
What is amp?
It's like an amplifier, like stereo. It's connected. These are speakers-ish.
I understand now. Yeah. When you said amp, I was thinking current, and I was very confused.
No, sorry.
Okay.
Amplifier.
Yeah,
but,
I mean, I think that post is probably like the simplest way to do it. Yeah, I don't know how I feel about the PLA glue, but
it seems to be working. Like I've done most of these joints already, except I think this one still needs glued together. But but like they seem to have just as much tension as the PLA itself. So I think we find and like none of this PLA or like the cardboard's not heavy. So as long as I don't put like this on top of it, I think it'll be fine.
True. Okay, looks pretty cool.
Thanks. We'll see how this like is just a version I imported here for.
I really don't like the cardboard, but it's fine.
I don't like it either. But I'm gonna have
you're literally
two
engineers. Why are you using cardboard?
Money, I think.
So dumb.
Yeah. But this is like a prototype I printed, and I was really happy this came out.
Are you
correctly.
printing these gears?
Yeah. Look. This one's stuck.
Wait, you froze. Oh. Okay.
They turned out pretty well. Like even those grooves, they're so tiny and they will come out really well.
Okay.
So.
It'd be cool to see. Looking forward to seeing the finished product.
Thanks. Thank you for the help.
Yeah, let me know if you ever have more mechanical questions. I'm happy to talk through stuff.
Will do.
All right. Anything else?
Nope. I'll see you at 9 for trivia.
All right. See you then.
There you go. Bye.